Okay, let's jump straight into this explainer. We're going to rapidly trace how a simple financial metaphor coined all the way back in 1992 transformed into a massive catch-all term for software development and how AI is completely shaking it up again today. It is an absolutely fascinating look at how we use language to bridge that eternal gap between writing code and actually running a business. Going into debt to move faster wasn't the mistake. Failing to pay it back was the problem. This quote directly from the creator, Ward Cunningham, hits the nail on the head. Borrowing time isn't inherently bad, right? As long as you actually make the payment. It was originally meant to describe a totally normal, reasonable trade-off.
Act 1, the 1992 origin story.
So we have to rewind to 1992. Back then, software was mostly built in one massive upfront push, the classic waterfall method. You planned everything, then you built it once. But working on a financial product called Ycash, programmer Ward Cunningham's team was trying out an early iterative approach. Write code, learn, and rewrite. He really needed a way to explain to his numbers-focused management why they had to literally pause and rewrite code before adding any new features. That refactoring process, that was the payment required to settle the debt. What's so interesting here is how Cunningham originally framed this debt. He didn't say it was sloppy or broken code, not at all. He defined it simply as the natural gap between a team's evolving understanding of a problem and the old code left behind. That old code was just based on an earlier, less mature understanding. It's basically a code lag compared to human learning. Act 2. Expanding the metaphor. Now, highly effective metaphors rarely stay in their lane for long, do they? Through the 2000s, this concept just exploded. Industry giants took the definition way beyond honest learning gaps. Suddenly it included careless choices, lack of knowledge, long-term system decay, the whole shebang. We literally went from one simple concept to a massive 7-category taxonomy over the span of a decade. The real turning point came when Steve McConnell formalized the financial side of the framing. Principal became the upfront cost to fix something, and interest was that ongoing tax you pay in extra effort for ignoring it. This was huge. It officially gave engineers and non-engineers a shared language to sit down and negotiate deferred costs. Fast forward to today, and the term has completely mutated into a massive catch-all. Seriously, it's thrown around in almost every sprint planning meeting you'll ever sit in to describe everything from legacy systems and confusing logic to outdated dependencies, or honestly, just any frustration a developer has where they wish they could rewrite the thing today. It's like a giant umbrella term now. The metaphor's drift got so extreme that by 2020, software architect George Fairbanks had to coin an entirely new phrase, technical debt. He basically created this term just so he could distinguish the original, highly specific 1992 concept of learning gaps from the incredibly vague, elastic way we use the term today to label pretty much any code discomfort. Act 3. The AI coding frontier. Right when we thought the industry had finally settled on a definition, generative AI coding assistants burst onto the scene and totally changed the game. And we're seeing early data showing that AI code takes on debt quite differently. Research from Pharos AI and CodeScene reveals it creates much higher code churn, meaning the code is constantly being replaced or rewritten. Why? Because these models generate plausible-looking solutions extremely quickly, but completely without that deeper human context. And this creates a brand new dilemma for us. Cunningham's original metaphor relied entirely on a human team's evolving learning process over time. But an AI model doesn't learn alongside your team, does it? It just spits out static output based on its training data. The fundamental underlying mechanism of the debt has completely changed. As AI writes more and more of our software, I want to leave you with this to chew on. Does our trusted 30-year-old financial metaphor still map cleanly onto machine authorship, or are we just stretching it to fit a reality it was never built to explain? It's a massive question, and for sure it's something every single engineering team is going to have to figure out in the years ahead.